Section 1.6, number 18. In this problem we are asked to take these two functions and do arithmetic operations with them. Add them, subtract them, multiply them, and divide them. So the first one we're asked to do is we're asked to add these functions. We're asked to find f plus g of x. Okay. Well, we just take our two functions, our x over x plus 1, and add it to x cubed. I would leave it in this form. It's a perfectly good form. Now, if you really wanted to write it as a single fraction, you certainly could. You'd multiply here top and bottom by x plus 1, and then you would then have nice fractions with the same thing on the bottom, and then you can add them up, so you'd get x plus x cubed times x plus 1 on the top and x plus 1 on the bottom. Okay. I don't think that's necessary, but so I would leave it as just this sum. Okay. And if you're interested in what this looks like graphically, it looks like this. So our original functions are in blue. We're going to have x over x plus 1. In green, we're going to have our x cubed. And in the red, we're going to have our sum function. You'll notice that our blue function blew up at x equals -1. Our sum function still has that property. We're still blowing up around -1. We have a vertical asymptote happening here. Okay. We still have a lot of the behavior of the x cubed because that's going to get biggest farther away from the origin, right? When we add things up, or when we subtract things, it's the things that are biggest that are going to dominate. So we're going to have the x cubed behavior dominating, where it gets arbitrarily large, okay, and the x over x plus 1 is going to dominate in the areas where it gets arbitrarily large. Okay? All right. There and there. Okay. Now let's look at subtracting these things. When subtracting, we take our functions and we just subtract them. F minus g of x is going to be x over x plus 1 minus x cubed. Now again, we could do the same thing where we multiply here top and bottom by x plus 1, but I don't really see a particular reason to do that. This function is going to look like, it's going to look like this. Alright, so we have x over x plus 1 minus x cubed. Okay, so we have our x cubed, but it's now flipped over the x-axis. So it should look something like this. Okay, right. This is going to be minus x cubed, and we see that when we have this subtraction here, we have that again. The x over x plus 1 is going to dominate when it gets arbitrarily large, and it's the negative x cubed that's going to dominate when it gets arbitrarily large. And so we get these, we get this behavior going up, coming down on this side, and this behavior going down, coming up on this side. Okay, we will still have our vertical asymptote that we had from x over x plus 1, because that's still blowing up around -1. Okay? All right, now let's look at multiplying these things. All right, so multiplying functions, f times g of x. This is, again, just multiplying our two functions that we have. So it's going to be x over x plus 1 times x cubed. Let me fill that in. Okay. Now remember, x cubed we can think of as a fraction of x cubed over 1. Anything that we can write, we can think of as a fraction of that over 1. And remember, fractions are multiplied top to top, and bottom to bottom. X cubed times x is x to the fourth. X plus 1 times 1, well, anything times 1 is itself. Okay. So this is the resulting function we get when we multiply function f and function g. Graphically, this looks like the following. So in this multiplication, our x to the fourth over x plus 1. Okay. Well, we are still blowing up around x equals minus 1. So we're still going to have that behavior, this asymptote here. Okay. Now, what else is happening? We have two things that are roughly 0 that are being multiplied together. X to the fourth is going to dominate at around 0. Right? Because anything close to 0 to a larger power gets closer to 0. Okay. Down here, the x to the x cubed is a large negative number. X over x plus 1 is a large positive number, and so a large negative times a positive is a negative, and so we get this thing that's down here. Negative times a positive is negative, so that should be negative. Here we have a positive times a positive, so that should be positive. Okay. And again, since this is large and this is not too close to 0, we're going to get our greatly increasing function here. Okay. Now, as these guys get closer and closer to 1, in this multiplication they're going to have less and less of an impact because anything times 1 is that anything. Okay. So if we take something awfully close to 1 and multiply it by something else, we get something awfully close to the something else, right? So we're going to get something very close to our x cubed. Okay. I don't have it on the graph because this graph gets very large. Next graph, our next function is we're going to divide. Right, and the last one is f over g of x. Okay, so in this one, we take our f function, x over x plus 1, we divide it by our x cubed. Okay. Now, we have a fraction divided by a number. This we can treat, of course, as x cubed over 1. Right? Anytime we have a fraction on the bottom of another fraction, we can treat that as a multiplication. X over x plus 1 times 1 over x cubed. Right? The 1 on the bottom goes on the top. The x cubed that was on the top on the bottom goes on the bottom. Now, we can cancel this x out with that, leaving our 1 on top. This leaves 2 x's still on the bottom. And so our resulting function is 1 over x squared times x plus 1. In the multiplication, it doesn't really matter what order we write it in. You could write it as x plus 1 times x squared. Okay. But this is a multiplication on the bottom. Order doesn't matter in the multiplication. I prefer to have my x's out front. If you prefer to have the x's in the back, that's perfectly fine. Okay. And let's take a quick look at this last graph and see what happens. All right. Now in this one we are dividing by the x cubed. Right? Our resulting function is 1 over x squared times x plus 1. This thing is going to have problems when x is equal to 0, right? So we're going to add in a blow up when x is equal to 0. We're dividing by something that's 0 on the bottom. X cubed is 0, around 0. So when we divide by it, well, dividing by 0 is going to cause a little blow up to happen. Okay. For the x plus 1, well, we're still going to have a blow up around -1. Okay. We're 1 on the top, so all of the action is happening on the bottom here. Okay. So the bottom, in between 0 and -1, x squared, well, the square is always positive, x plus 1. This is between, x is between 1 and -1, which is less than 1, so this thing is always also going to be positive. So we're going to be positive here. Above 0, the x squared and the x plus 1 are certainly both positive, so we're going to be positive there. Below -1, x plus 1 is going to be less than 1 here, right? It's going to be negative, so it's going to be less than 0 here. It's going to be negative. Okay, so x squared is always positive. X plus 1 is negative in this region, so a positive times a negative is a negative, which means we are below the x-axis over here. Okay. So our blow up is going to have to go off to -infinity in this direction. And again, as these things get larger, as the bottoms get larger, the thing is going to be going to 0 in both directions. So we're going to have a horizontal asymptote at 0. Okay. So that's certainly more than you need to do for this this problem, but I thought I would show you the pictures of what these things look like when they're